Hello again, and sorry for the delay. Today we will talk about one of my best, the one I like the most features of Haxe, which are macros. Maybe a few of them have heard about macros already, but maybe you still don't know what they do exactly, or in which case you can use them. So we'll do a short streaming today, maybe half an hour, so we will not go into the deep details, but at least I want you to understand what exactly are macros, how they are working, I mean, on the global point of view, and what they are used for. And this way, if you want to learn more, if you have a specific use for it, you will know at least, and you will be able to start using them in the place you might have use for it. So I will open a new Flash develop or X develop application here. Okay, we'll create a new project, just a new project. It's new. How do you open a new project here? Oh, it's a project, new project here. That's, sorry. Here. So I have my main class, which I will just clear, because we will just focus on code today, not much about games or display. So macros. Okay, I will start to show you a difference between a normal call and a macro call. Okay, when you declare a macro first, a macro is just like a normal function that you execute here. So I will just add the function getDate, which return date no toString. Okay. Okay. This is, if I don't, this is perfectly valid. This is a thing that I can do. I can trace getDate, and I can run the application. It compiles and starts, and I should be able to see something on the screen. I don't know what is not showing. I have to check my, oh, it's showing in FDB, so it's showing in the console here. So here you can see that the macros there is no macros here at all. We just trace the date here, and you can see it's 2 past 10 here. And if I write a macro, and if I turn this function into a proper macro, the difference is that instead of static function being called at runtime, the macro call will be performed at compilation time, which means if I start seeing, okay, I need something a bit more. Yeah, the macro actually cannot return a value. It has to return a program, because the macros is a function that executes at compilation time. It has to return a program, not the value. So actually there is a quick way to turn an actual value into the corresponding program using this. So I will just write it this way right now and compile, and just we'll look into this afterwards. Okay, here I'm writing a thing that say this is a macro function, so it runs at compile time, and at compile time I'm executing this function that gets the current date, and here I will turn $v stands for value. I will convert this value into the corresponding program. Okay? And here, when I trace this, if I run, I get in my output, I get here the time for now. But if I start again my my code as a Swift, well, obviously it's of course it's not working because it's not. Yeah, I will disable the debugger like this with so the result on the screen. Okay, here. So here I can see the result on the screen. It say 13 and 31 seconds. And if I restart, it still says 13 and 31 seconds because it's not the time at runtime. It is the time that was inserted into the program at compilation time. Okay. So basically, what you need to know is that when you call a macro function, it runs at compilation time. It doesn't run at runtime, at the time you start your program. But instead of returning a value, it returns a program. So we can do actually quite interesting things, saying, okay, I can actually do get date and return a program. So this is a program I return. I use macro for the function to say, okay, this is a function that gets called, and I can do macro also for an expression saying this is a program I want to return. Okay, so I can return for y in 0, 10, trace y. Okay, but this is just a program I return. This is not the program I will execute because it is a macro expression. It says return this program when I call get date. So if I start this, you will see it will trace from 0, 9. Pretty much the same if I had written this 4 here like this. Okay, this is exactly the same result because the macro returns this program and the program gets replaced at the place get date has been called. Okay. Now, of course, macro can also have parameters, which is nice. For instance, I can have here a number and here, but if I do this and I compile my program, it will say here, it will say identifier n, because this program gets inserted there, like if I have written this exactly the same. Okay, and of course it doesn't know n in this scope. Okay, so if I write this, it works, but this is not really what I want to do here. What I want to do is to insert here the value of n, which is the parameter I get from date. Okay, so here I will make a loop. You can start and compile, and you see it's exactly the same. So I return a program that gets some parameters from this command, and it's actually the same thing if I have written this. Okay, so I think you can start seeing how it can be interesting to be able to kind of build program and return them for instance, for optimizations. You can do a lot of things with this by building programs that somehow gets optimized by using several parameters. Instead of doing some runtime checks, you can do some like compile time checks and actually produce a small program that will be only the part that's executed at runtime. Some kind of the work can be done at compile time and some part of the work is done at runtime. You can mix between the two. But that is not the most important thing. What is nice here is that you can also examine the types of things, and you can also manipulate the program. For instance, here I can do, for instance, here. So here, if I will keep my, it's not detect anymore, it's a loop. We call it loop now. Just evolving on the previous example. So here I have a variable a, and I pass it to the loop. So you might think, okay, it will loop 50 times, but this is not possible because here you are passing a value at compilation, but it doesn't know yet the value it will have at runtime, because this a you're passing here is not the value of a, because the value of a is only known at runtime when you will enter the main function and assign it here. But we are not at runtime in the macro function. We are at compile time. So here, when we're passing a as a macro parameter, we are actually passing an X macro expression. Okay. And here, I can actually use this directory, this expression here, to insert the A expression into my program here. And here it compiles and it runs, okay, from 0 to 50. So here is also pretty much the same as writing this. But instead of writing, actually passing the value of A, I'm passing the program A. The program which is the expression of A. And I'm inserting it into this program that I'm returning. Okay, I hope I haven't lost all of you yet, because we'll get started with more interesting things. So, one of the most maybe used macros right now is the build macros. They are the most often used macros. So a build macro is another kind of macros that doesn't get called like a function. So it's not it is a function, but it's a macro that you'll declare using this syntax, metadata build. So this is a metadata. You can put any metadata everywhere, like foo bar here. You can have parameters, 5, hello, and you can get back this metadata at runtime using the X metadata API. And when you add this double dot here, you will get, actually, this is just an annotation to say it's a compiler metadata. It's a compiler specific metadata, so it might trigger something on the compiler. Okay, so I can actually use a build macro on my class main, saying my macro dot build. Okay, and we create a new class, my macro. Okay, we'll have a public static function build. Okay, and let's say right now it returns 0. Okay, if I compile and it runs, okay, no problem. Okay, what does it do exactly? When initializing, when compiling the class main, it will call the macro build, and the macro build can actually do quite a lot of things. It can receive, so you need to import X macro context, which has a lot of functions for macros works. It's like an API when you're inside a macro. It's an API for macros programming. So you see you have a lot of functions you can use to get a lot of information. So here what we can do is that we can, for instance, get the fields, which are the get build fields. Okay, basically when you get the build fields, you will get all the program, all the fields. So the main function here, we can add a few ones. Okay, and here if we trace the fields for f in fields, trace f.name, for instance, you can see at compilation time. So when I'm compiling, I think I will disable compilation server. No. Well, I can. When I'm compiling, you see here A, B, main. Okay, this is the three fields that I get inside my build macro. And the nice thing is that I can actually know what kind of fields it is. For instance, you can see here A is a field var with a pass int, and the main is a function with arguments, and you have the position, and you have you even have the content of the things. If I trace, for instance, hello world, and I compile, you see here I have a call to trace and hello world. So you get this kind of big enum which represents the program. So here the build macros will get all the fields that my main class has been declared with, and it can actually change them. So here I'm just tracing their names, but for instance I can and it can change them, and after when it's done it returns. For instance, if I return an empty array, it will say main doesn't have a static function main, because the static function main that we need has been removed by the macro. Does it make sense? So this way we can actually do a few things. For instance, we can for f in fields, if f dot access, well, we can do actually, for instance, do push a static. Okay, so here what we do is that we turn all the fields into static. So here if I can do trace a plus b, okay, let's say equal 3, equal 5. So if I try to compile here, it will say cannot access a in static function. But if I had my macro, it will actually compile and print 8, because it will change this field into a static, and this one too. Okay, so here you get the kind of macro that manipulate a class, reads the variable, and changes. So maybe you can start seeing what kind of things you can do with this behavior. For instance, you can modify the fields. You can actually automatically change them into like properties. You can manipulate the whole code of your class into to change it, to generate a lot of additional code. Well, there's a lot of different possibilities that you can use using Brill macros. So we can maybe look at one specific example of macros. Let me find something that is not too much hardcore. What? Do you have any questions so far? I'm checking on the chat. Uh, what do we have here as quite macros? I tend to write quite a lot of advanced macros for a lot of code generation. So they might be a bit overkill to showcase to you right now. Yeah, I have one that I like. Okay, I have one that I like. Okay, we will do something funny just to show you. Okay, let's try to do that. I don't know how it will go, but at least we will try. Here we have a build macro. What we will do is that we'll just to show you how funny it can be. We will do a request on Google. So we'll get XHTTP. Why is this? Okay, it's having this automatic import that I don't like. I will disable it right now. Yeah, I'm not using this computer like on a daily basis, so I have to do a few setup for it. So here, XHTTP, and we can call on google.com. We can trace the results. No, it's a http.requests. We want to do it. Request things like here. So yeah, here. Okay, we get this output. It's moved. It's returning them on French version. Oh, maybe slash. Let me check. It says moved on this. I will try to paste this right now. Okay. Okay. Here we get, so here we trace and we get the whole like Google homepage. Okay. Now what we will do is that we will actually parse this. We'll just do it a quick regular expression, maybe. Using matching ID equal this and we create a new map of IDs while we match the ID we get matched. I think it's 1 here, and we set it. We can push it actually. We don't need a map. Okay, and then H equal matched. Right, I think that's it. What's wrong with this? Here, and trace IDs. So this is all happening at compilation, remember. So here we get all these IDs which can be found on the Google homepage. And what we will do is that we'll get our fields, okay, which is context get build fields, and we will add a field to it. So for each of the IDs we found, we will add we'll define a type, a new type. So we'll create a new field which is Google IDs. So it's a X macro. Well, it's a field. Let's import. Yeah, it's complete right, but let's import it. Okay, so it's a field, and it requires a few things. It requires a name, so we'll name it GIDs. It requires a position. So position is a place when it's declared in the program. So here we can do context get no, that's current position. So that's the position of the program at the place we call the macro. So basically this is this position. So if you get an error with these things, you will get an error at this place. Okay. And you can when you declare a new field, you need also to declare this kind. Okay. I say kind is what kind of field it is. So we create a variable, and it needs a type. Okay, and we g type okay. Well, actually we don't. Yeah. Let's create the type. And here var g type. It's a complex type, so we will use a t anonymous, which is required. Well, it's not a t anonymous, it's a t anon, I think. No, t anon is a. Let me check. Oh, here you get the expression. You can check it on the Google on the X website. You get all the what is a position. So position is a file, and a position in the file, the different constants within an integer, a float, etc., and all the operations that are done in the code. And you get the different variables and all the expressions which are the program you're manipulating in macros. And finally, what I want to check is here. Oh, it's actually a t anonymous here. It was, yeah. Okay, so yeah, and it takes fields. So for each ID, I will declare a name which is the name of the ID. I will add a position which will be also be context current pose, and I will add a kind which will be a var. And here I can use this to say macro double dot string. It will take this type and turn it into a complex type. Okay. And here is my type. Okay. So I compile this. It compiles, and I return. Okay, and I will put these fields, this field we create into the field this. So fields dot push gids and return fields. Okay, that's a bit of code, and I guess maybe so. Let's recap a bit. We make a error request. We extract all the IDs from it. Here we get the build fields of the class we currently building, and we return this later. Here we create an anonymous type. So basically, for each ID we have, we will have ID1 string, ID2 string, etc. So we create a type at compilation time. Okay, we generate it there, and here we create a field GIDs. This is a variable, and actually we put it as a static, and we add it to the fields of the class and we return it. So just to show you, we did this there, and usually that means that if I do this, I get as a completion all the IDs that come from the Google page. Okay, you can see here. Well, that's probably not very, I think they are quite small IDs. And they are all typed as strings. So if I do this, I can do like two lowercase. So I think that's pretty, that can show you what kind of a way to generate some code by extracting some data from other files. So this was just to show you like a full example. When you write yourself the macros, you generate a type, you add the fields and to the main function, and you get completion, and everything is kind of, when you're there, things feels quite magic. You know, you say I want the ID of this, and I get that, and I mean that sounds magic. Actually, we can modify a bit this by saying, okay, we can make a macro function also with that. We can actually do something like this. Get IDs. Well, we could do that, like for instance, pass the, well, we can pass the real, for instance, here. Here, and I can pass it there. Okay, so here I'm creating this here, but if I use, for instance, Amazon.com, I will get, if it returns IDs, maybe it's also doing some kind of redirection. Let's see. That's something else. Yeah. View output. Yeah. What is this? Yeah. It's using single quotes. Yeah. So we can modify our macros to accept both double quotes and single quotes. Here. And here, when I do GIDs dot, I should be able to get, I'm tracing a lot of things already. So H, it's saying duplicate field declaration because we have several times the same ID. So we can first, let's remove it and push it afterwards. And finally, we can get here. We're here. Okay, here we have all the IDs automatically extracted from the Amazon.com thing. So if you have, for instance, a template, a web template that have these IDs, you could actually generate them at compilation time, look at all the IDs in your template, and generate some actually street typed code from this template to access all this thing. And you could even do, when I access an ID, it will call a function that actually fetch the it from my document and returns the node. And suddenly you start getting some kind of street typed template system, which is, I think, pretty neat. So, is there any questions for this? Let me check. Macro sort of aligning. Yeah, macro is kind of aligning. I mean, aligning is maybe a specific application of macros. So in aligning, you just kind of replace the variables in your program. When you inline something, you just inject parameters into the proper place. But macros can do much more by actually compiling, at compilation, by executing some code and by having side effects, such as making an HTTP call or reading a file or even writing files. on the local file system. You can access all the compilation parameters, all the defines. You can do, I mean, everything you can do at using a system language. You can do it in macros. Other thing is macro unique feature of Haxe. Well, I think there's been several attempts. It's called macros in general are called meta programming, which is a way to have have a manipulation of programs into running at compilation time. So it's not something which is entirely new, but I think in the kind of mainstream language, I knew only, I think, Scala had them, but it was after Haxe, so we were definitely ahead. And I think the kind of the amount of control and you get in Haxe is not, I haven't seen that in other programming language. So all the things you can do right now in macros in Haxe, I would guess we are quite advanced in that area. Maybe there is a few research programming language which have something more. But yeah, in terms of mainstream language, well, I think Haxe is pretty much advanced in that area. Yeah, so maybe there is no more questions on this. I can show you a last example of macros. Let me think for a second what we have in the standard library eventually. So yeah, you can imagine you can do a lot of things. The first thing you can do is to modify some program and call a function that does some kind of a lot of tests and returns a smaller program than doing a lot of runtime checks. One of the other things you can do is to actually manipulate type and do a lot of code generation thing instead of, for instance, doing code generation and generating HX file. You can get much more streamlined generation. Let me check what we have in terms of macro here. Yeah, well, I will show you this. Okay, this is just a follow-up of my last time talk on this. So if you use IPS, which last time I was talking about IPS, it has this resource manager, which is based on macros. So here, when you have a, let's say, we create a new folder called res for resources, and we can put a lot of files into it. I will just copy some files here. Let me check. You can copy, I'll copy MP3, for instance. Where is it located? Here. Yeah. Oh, this works. Here, and you can copy. I will copy also a few other files. Okay. This, and texture, for instance. Okay. Okay. So yeah, I have copied a few files into my rest directory here. You can see. And when I'm using #xd res of IPS, I get completion. You can see I get texture, vic1, and data, which are all resources that gets stored into my rest directory. So what the macro does here is that it reads the directory content, look at the different files there is, and if I create, for instance, a new folder, say, for instance, image, or maybe music, let's say music, and I put this music into there, I can do rest.music here, and I get my vic1 music. Okay, so and this vic1, because it's a music, I can actually play it here with a volume, which I can't do, for instance, for texture here. Here I can convert it to texture or to a bitmap. Okay, it's based on file extension. So let's look a bit at this res file. So here you can see Haxe has this dual macro that I just showed you before, and it executes this file tree build macro, and the file tree build macro will actually create a file tree, look at the path, look at the different extension. It will also check, it uses context define. We check if we are in Flash, in JavaScript, or in C++. So you can actually do a lot of things interacting with the compiler. And here I will just, it does build, so it will build, it will do a scan. So for each of the fields, it will actually create a lot of things. Use scanrec here. So all the files, it will read the directory. For all the files, it look. If it's a directory, it will recurse. If it's not, it look at the extensions. And if the extension is found, it will handle the file, which based on the extension will generate some macro code, which is a given type and a given loader call. And here this will actually produce a lot of code. So actually, if we want to look at this, we can use -d dump equal pretty in our command line parameters. And when you compare this, when you compare this and you look at the result, well, it's not showing. Yeah, here you get this #xd rest dump, which have here data, #xd resource. Actually, we have this never because I think it's being removed by yeah, because it's meant to be removed. So only if you use it. But okay, let's say I'm using this music vic1 play. If I do this, I compile, I will have in my main class here, you can say #xd, it gets compiled into this function main, #xd rest get loader. This card gets removed actually, so it's not a problem. And load sound with a path of my music.play. So this is the kind of things macros are already used to kind of generate these things and still having very nice API on your code. There's a lot of different ways to use macro. So if you're interested in the topic, I suggest you search for it. You look into the different libraries that are out there and how you can write your own. It's a bit tough to get started at first because you have to figure out how to represent the type of the compiler, the fields, the expression. But once you get used to it, it becomes very easy to use and and you can get a lot of control on the things you're doing and on the output you get. So if you're interested into metaprogramming, if you want to create like great API, don't forget about macros. And thank you very much. That's all for today. And see you next week. Bye-bye.